Well, thank you for joining us on exercise 3G. I'm going to be looking at 5 part B. This question says, given the complex number z equals a plus bi, where a and b are both elements of the real numbers. Find the relationship between a and b such that 1 minus I over the conjugate of z is purely imaginary. Purely imaginary, which means there is no real component. There is only an imaginary component. Therefore, what we can say is the real part of our fraction, our value here that we're given, is actually 0. So let's work out what is 1 minus I over the conjugate of z, and then get the real component and let it equal to 0. So let's go 1 minus I over the conjugate of z, so it's a minus bi. Therefore, let's multiply the numerator and the denominator by the conjugate of a minus bi. So we need a plus. So it's a plus bi. And let's expand that. So we get a times 1 times a and 1 times bi. And negative I times a is negative ai, and negative I times bi is negative bi squared. That's the numerator. The denominator is the difference of 2 squared, so it's a squared minus bi times bi is b squared I squared. All right. Let's replace our I squareds. Because I squared is in fact negative 1. There is a negative b I squared there, so negative b times negative 1 could be replaced with b. There's also a negative b squared I squared, so that could be replaced with negative b squared times negative 1, which is positive b squared. So let's replace those. So we've got a plus bi minus ai, and we replace that with plus b. And instead of a squared minus b squared, it becomes a squared plus b squared. Okay, let's take the real components together, and we've got a plus b as the real components, and the imaginary components is b minus a. And that's all over a squared plus b squared. So the real component of our original value is in fact a plus b over a squared plus b squared. And we want that to equal 0 so that it's purely imaginary. If it's equal to 0, therefore the numerator has to be 0. Therefore, a has to equal negative b. So for this value to be purely imaginary, a must be negative b. I hope this has helped. Until next time, stay happy.